Hey everyone, welcome back to my channel. Today we're going to be working on another Leetcode problem. This is going to be a time challenge of 15 minutes. So if you guys have seen my channel before, I have done problems where some problems I just pick from random, and as long as they are easy difficulty for the 15-minute challenge, I try to do them. So I already have it sorted by easy. Last time I worked on it was sort of random. But in easy, it's going by acceptance rate. So I'm going to try to work on one that has a least acceptance rate and a problem that I have not worked on in the past. So let's try this one. And let me start my timer. Okay, so the problem number is 414, third maximum number, and I have never worked on it in the past. Given an integer array nums, return the third distinct maximum number in this array. If the third maximum does not exist, return the maximum number. Okay. So you have an array and you want to return the third highest number. So the third highest number is 3. And here the third highest number is, so if the third maximum number does not exist, return the maximum number, which is 2. And here it's 1, 2, 3 again. The third highest number is 3. Even though we have 2 twice, but it needs to be distinct, right? And the constraints are 1 is less than or equal to nums.length, which is less than or equal to 10 to the power 4. So nums will not be null or empty. So negative 2 to the power of 31 is less than or equal to, so the number does have a negative possibility. One thing I just wanted to check is, what if you had something like 3? What would be the third maximum? Okay, so we expected 1 to be the third largest. The first largest is 3, the second largest is 2, the third largest is 1. So let's go over the steps. One thing is for sure that we have duplicates, so we want to ignore these duplicates. So one way of doing this problem is to, like a brute way, force way, is to actually do it. Sort the array and iterate from left to right, because that's going to be from the third largest, right? Is that the third smallest? Like, what if we had, 4 and then 5? Right now it gave us 1, right? So this should give us 3. Yeah, so it's going, well, that could still be from 4, 5, 7, 8, right? So 8, 7, 5. The third largest would be 5. Okay, cool. So instead of going from left to right, we would go from right to left, and anytime we get a number lesser than the current number, when we get to the third unique index from going right to left, we return that number. But I think the simpler way of doing this is actually using a data structure called a heap that uses a priority queue. So we can make like a max heap, which would automatically, an insertion, would make it unique. Let me think. If we use a heap that's still going to contain duplicates, what we can do is use like a set, but instead of using like a hash set, because that is unordered, we can do it like a tree set. And a tree set will be of log of n on average case. And then we will do like a 1 pass from the back, and then we add everything from that tree set to like an array. And then once we do that, then we can just iterate through that, so that new array. So what we can do is, let's just do this as nums.length equals 0, or nums equals null, return 0. Let's do int output equals 0. Let's do tree set of integer. Tree set. So there's int I nums, and then we add everything to the same set as add I. Once we've added everything, in the tree set we go from, so the tree set we can iterate forward from least to, so basically it's an ordered set. So if you go from the forward to the end, we will just need to go to nums.length minus, so int final index equals nums.length minus 3, but instead of 3 it would be minus 4. So what we do is for int I, and then set, how do you traverse a set? And I'm not sure if we can traverse it this way. I don't remember the whole API. And then what we can do is, if actually a better way is for set dot poll. Oh, okay, so we can do poll first and poll last, right? So while okay, so while, okay, so if you go from the back, it should just be 3, and final index equals 3. Is greater than 0. We just do set dot poll, and we just do output equals set dot poll, and then final index minus minus, and in here we just return the output. So we sort this using tree set. If the numbers are not sorted, then it uses log of n for insertion, so O of log of n. So now we set the final index to 3, which means it's going to come here and it's going to contain unique values, while final index is greater than 0. Dot poll last. So it's going to remove like 8, 7, and then 5. And then it's going to return the output. So this should work. Okay, cool. Let me just run the sample test cases. Oh, also, and set that is empty multiple test cases. Which one is it failing on? 1, 1, 1, expected 1, 2, 1. Oh, okay. This one is failing because okay. If set dot size is less than 3, then what we can just do is return set dot poll last. Let's try that, and let's try to submit this again, and let's try to submit this. Okay, cool. So this worked faster than 24.71. Let me know how I could have improved. Thanks again for watching, and bye.